right, so today what I'm going to first look at is I'm going to work some questions for you out of 1.3 from your homework. Then we'll look at 1.4. So we're going to begin with some questions out of your homework. Now, some of these I will solve out completely. Many of them, though, all I'm going to do is set them up. So I'll get you to the point where you have an equation, and you'll have to solve that equation on your own. So listed are the questions that we're going to be looking at. I tried to pick several of each type. So let's begin now by looking at question number 9. And question number 9 is a problem that involves a total. So Gloria collected 18 fantail and comet goldfish. There were 10 fewer fantails than comets. How many comets did Gloria have? So what we're going to look at first is what we've got. So we've got two types of fish. We've got fantail and we've got comet goldfish. And that first statement tells me that the total, so that's both fantails and the comet goldfish, is 18. So let's begin with that. So my total is 18, and that's the fantail plus the comet goldfish. So that's what we've got there. Now what we're going to look at is we're going to look at how they relate to each other. And it says there were 10 fewer fantails than comets. So if we look at the fantail, we'll just call that fan. That's going to be the comet minus 10. And the comet goldfish, we have no idea. So we're going to call the comet goldfish X. So this is what we have so far. So there were 10 fewer fantails than comets. So let's now go ahead and rewrite this in terms of our variable X. So then fantail goldfish are going to be X minus 10. And the comet goldfish are simply X. So now we can fill this in as X minus 10 for the fantail. Comet goldfish is X, and that equals then 18. So the X's can go together. That gives you 2X minus 10 equals now 18. We'll add 10 to each side to move that over. And now we have 2x equals 28. We'll divide by our 2. And that gives me then x equaling now 14. So that's what we have so far. Now we're going to use this to answer the question. Okay, so we need to make sure that we answer this question completely. So what does the question want you to find? Well, question 9 says, how many comet goldfish do we have? Well, X, what does X go with? X goes with the comets, so X is the comets. So we found our value of X to be 14. So that means we have 14 fish here. So we've got 14 goldfish that are comet goldfish. Now, how can we check our answer? Well, if we have 14 comet goldfish, X was 14. So now if we have 14 minus 10, we get 4 fantails. And the 4 fantails and the 14 comet goldfish add up to give you the 18 total fish. So that is how we know that we worked that one out correctly. Question 11. Similar again. Several of the questions from 7 through 11 are questions that involve totals. So question 11. In a recent school board election, the two candidates for president received 1,957 votes. The loser received 1,269 votes fewer than the winner. How many votes did the winner receive? Okay, so again, how would we set this up? Well, let's think about our total. We know we have a total number of votes. And the total number of votes is 1957 here. So that represents both the winner and the loser. So that represents our total. Now what are we going to look at? Well, now we look at each one. And we see how they relate. So what do we know here? Well, it says we know that the loser received 1,269 fewer votes than the winner. So the loser is going to be the winner minus 1,269. We do not know the winners. So we're going to call the winning number of votes X. So now we can rewrite this. We've got the winner as X. And we've got the loser is going to be then X minus 1,269. Rewriting our total. So we've got the number of winners, which is X. We've got the number of losers, which is X minus 1,269. That equals 1957. Adding, that gives you 2X minus 1,269 equals 1957. Add your 1,269 over. Now we have 2X equals, adding here, should we add these together? We've got 1957 plus 1,269. Add those together. We get 3,226. We'll divide that by 2. That gives us then X equaling 1613. Now, what does the question specifically want you to find? Well, it says how many winning votes were received. So how many people voted for the winner? Now, what is X? X is the winner. So that means then we got 1,613 votes for the winning candidate. That's question 11. So 9 and 11 are very similar, and 10 is going to be worked out pretty much the same as 9 and 11. So I'm going to leave question 10 for you to try on your own. But work it off of 9 and 11. Now we're going to move on to a percentage type of problem with question 12 here. We'll do 12 and then we'll look at investments. So let's look at question 12. So after receiving a discount of 13.5% on its bulk order of typewriter ribbons, John's office supply pays $5,882. What was the price before the discount? Now, how does a discount work? Well, a discount is going to work by taking it away, by subtracting. So let's figure out what we've got. We know our discount price. And our discount price is going to be the original price that the normal person would pay minus the original price times the percentage discount. So that's what we've got there. We've got our discount is going to equal the original price minus the discount percentage times the original. And we know our discount percentage in this case is 13.5%, which is then 0.135. So that's what we've got for our percentage as a decimal. We don't know the original price, so we're going to use X to represent the original. Now we can fill it in. So the discount price that we paid on all of these ribbons was $5,882. That's going to equal the original price, X minus 0.135X. Now we can work this out, because this is your discount here. That's like your sales tax. It's no different than sales tax. We always have to take a percentage times something else. Percentages can't just be left out alone. They have to be combined together. Now remember, that is 1x here. So if in doubt, you can put the 1 in front. And 1 minus 0.135. Well, that gives you 0.865x there. When we're done, now we can finish it by simply dividing. And now we've got our X, which our X is now $6,800. So the original price without our discount was $6,800. So that would have been the price that we would have had to pay if we didn't use our discount. The next problems that we're going to be looking at are going to be mixture and investment. I am not going to solve these completely out. What I'm going to do is set up the equation. You can then finish it once the equation has been set up. So there's a lot of these. I'm going to set them all up, but I'm not going to solve them. So we're going to go ahead and begin with question 13. So I'll put question 13 on the screen here. And we'll read it and go through it. So question 13 is an investment problem. So Marty received an inheritance of $70,000. She invested part at 11% and the rest at tax-free bonds at 10%. The total investment was $7,400. Find the amount invested at 11%. So let's see what we've got here. Okay, we're going to use dollar signs to represent the different investments. Remember, we always have a total over here. And this is our total amount. Okay, so what do we know first? Well, when we read this, it said that Marty received an inheritance of $70,000. So that means my total amount is $70,000. So that goes here because that represents your total amount. Remember, each of these has an amount and a percentage rate associated with it. So $70,000 is total. Now we have no idea how much is in our first account. We have no idea what's in our second account, so we can't just use X again. What we have to use is our total minus X. And in this case, our total is that $70,000. So it's then going to be $70,000 minus X there. So we've taken care of the amounts. Now we've got to work through the percentages. So we've got part at 11% and another part at 10%. Next, we'll look at our interest. And our interest is the amount times the percentage rate. So we'll use this for each one of our funds, and then we'll talk about our total interest. So our first one, we've got an unknown amount, X, and 11% is 0.11X. Our next one is 0.1, that represents 10%. And how much is in there? 70,000 minus X. And what is that going to equal? Well, that is going to equal my total interest and my total interest from the question itself is that $7,400. So that's your equation. You should be able to finish it. Now, how would you finish it out? I'm not going to do any more, but you would distribute through, and then you would finish it. You would solve it for X. You're going to get your two different amounts, and you're going to find the one that is associated with the 11%. So you need to finish this one from here. I'm not going to work it out anymore. It's just simply solving that equation down. That's 13. 14 is, again, very, very similar. Another investment problem. So Walt made an extra $9,000 last year from his part-time job. Part of the money went to 8%. Part of it went to 6%. He made a total of $640 in interest. How much was invested at the 6%? So again, we'll use a dollar sign to represent the money in these accounts. So what do we know? We know we have $9,000 total. So the $9,000 is going there. That's your total amount is $9,000. We don't know how much is in either one of these. So what we're going to have to do is call one of them X and the other one the total minus X. So the first one we'll call X, and then the second one, we don't know how much is in here, so it's going to be 9,000, which is our total, minus x. So if you don't know either one, you call one of them x. The other one is the total minus x. Now, what about our percentage rates? We've got 8% and we've got 6%. Your interest is the amount times the rate. So let's build our two parts of our equation. So the first one is unknown, 8%, so it's 0.08x. That's 8%. We're going to add to that 0.06 times 9,000 minus x. That then equals our total interest, not the amount, total interest. And our total interest is $640. Again, you're going to have to finish it from here. So you're going to distribute through and finish it. Make sure that you answer the question, because x may or may not be the finished answer. Because x goes with the 8%. So then how do we get the other one? 9,000 minus whatever you find. So I always like to try and get both of them, and then just circle or highlight the one that's my answer. So that's how you set up question 14, and that's an investment problem. Now we'll look at 15. We're going to set all these up just to make sure we know how to set them up. But you're going to have to finish them yourself. Solving the equation is not the difficult part. So question 15. Roberto invested some money at 6%. And then $4,000 more than twice this amount at 9%. From his two investments, he made $34.80 in interest. How much was invested at the 9%? So let's see what we've got here. This one's a little bit different. We've got an amount, and we've got a percentage rate. So Roberto invested some money at 6%. So we have no idea. So we'll call that X. The percentage rate is 6%. And then he invested $4,000 more than twice this amount. So that's 4,000 plus 2x. And that was at 9%. The total amount is simply adding across. So that would then be, if we add across, 3x plus 4,000. You don't have to fill in the total amount on this one. I do, because otherwise students get confused. So just add across. That way you don't have any missing spots. Next, we're going to work with our interest. And our interest is the amount times the rate. And this will be our first one. And this will be our second one here. So our first one is 0.06x. Our second one is 0.09 times 4,000 plus 2x, and then it equals 34.80. That's your total interest. So you can finish it from here. Again, what would you do? Distribute your decimal through, and then you can finish it. I'm not working these completely out because I want you to finish it on your own. I don't want you to just copy things down, so that's why I'm only getting you to the equation. The next several problems are mixture problems, and they're involving percentages again, but we're mixing chemicals. So we're now going to look at question 16. In a chemistry class, 8 liters of a 4% silver iodine solution is going to be mixed with a 10% solution to get a 6%. How many liters of the 10% solution are needed? So again, we're going to use boxes instead of dollar signs, but very, very similar to question 15. Now, what do we have to remember? We have to remember that box number 3 is what we want. So this is what we want at the end. So this is what we want at the end. So what do we want to end up with? Let's work that one out first. So we want to get a 6% solution. So that's our goal, 6%. So that's going to go there. That represents our goal, what we want at the end. How do we get there? What do we have? We currently have 8 liters of a 4% solution. So that's going to go in box 1. We're going to mix that with an unknown amount, X, of 10% solution. And remember, the amounts add across because 1 plus 2 is 3. So adding across, this is X plus 8. They just add across. Now we should be able to build our equation and finish out this question. Instead of interest, we look at the pure. And the pure is the amount times the percentage rate. First container, 0. Watch your number of decimals here, 0.4 times 8, because that's 4%. So make sure you use the correct number of decimals, plus 0.1x. That's your second container. That then equals 0.06 times x plus 8. You can then finish it from here. So you should be able to finish it from this point forward. We've got a few more to look at. Question 17 is a little bit different. So question 17, we're looking at an antifreeze solution in a car. So let me put this up on the screen. We'll read it, and then we'll go through it. So it is necessary to have a 40% antifreeze solution in the radiator of a car. So that's what we want. All right, we want a 40% solution. The radiator now has 40 liters of a 20% solution. How many liters of this should be drained and replaced? Very important, they're drained and replaced with 100% antifreeze to get the desired strength. So here's an analogy. Let's say we're making sweet tea for a banquet, or you run a restaurant, we want to make sweet tea. So what we do is we make our 5 gallons of tea. and we forgot to put the sugar in. So we want to maybe put in 3 cups of sugar. Well, if we've already got the 5 gallons of tea made, we can't just add the 3 cups of sugar to it because it would overflow. So what do we have to do? We want to add 3 cups of sugar in, and the container's full. We have to open the spigot at the bottom, take out 3 cups of tea, so we can replace that with 3 cups of sugar. So it's going to be a subtraction, and then we add it back. So what we're going to start with is box 3. What do we want in this car? Well, in this car, we need to make sure that we get a 40% solution. So that's going to go over here in box 3. So that's our rate there. As of right now, that's going to be box 1. So the car comes into the shop right now with 40 liters of a 20% solution. So he's been watering his coolant down. For the summer, we need to strengthen it back for the winter. So we're going to have to add in some unknown amount X, and that's going to be 100% or pure antifreeze. Okay, now, we can't just add this X in because we would overflow it, because all we can have total is 40 liters. So this one's going to be 40. Now we're going to drain and replace, so that means we have to take it out and put it back. So whatever we take out over here, we have to add back in. So this one's going to be 40 minus X. So that's like that 3 cups of tea that we take out to add in the 3 cups of sugar. Now they do cancel out because a positive and a negative X cancel each other out. So what does our equation look like for our pure now? Pure, remember, is the amount times the percentage rate. And what does our equation look like? Well, our first one is 0.2, that's 20%, and that's going to be 40 minus X, plus the second container, which is 100% or 1, so we'll just put the 1 here, X, and what does it equal then? Well, it equals 0.4, that's 40%, times your 40 liters. And you can finish it from here. Right, so you can finish that equation out and find your value of X. We've got a few more to look at, and then we'll start 1/4. Question 18. This one's very similar again, except instead of having a percentage, we have a value of this coffee. So coffee merchants, what they do is they make blends of coffee. So they mix different types together. These coffees cost different amounts for the quality and types of beans, and then they're ground together to make a mixture or a blend. So we're going to read through this one. So we've got 2 types of coffee. We've got a coffee that's worth $3 a pound. We're going to blend it with 60 pounds of coffee that's worth $7 a pound to get a mixture that costs $3 a pound. So we're going to set this one up in a very, very similar way. Box number 3, again, is what we want at the end. So we've got our 2 boxes here. And we'll have the amount. This is going to be the number of pounds. And then instead of a percentage, we'll have the price. So we've got some coffee that's worth $3 a pound. Now we don't know how many pounds of coffee that is, so we're going to use an X. The price is $3 a pound, so we'll put a 3 there. Then we're going to mix that with 60 pounds of coffee that we have on the shelf. And this coffee is worth $7 a pound. We want these to go together, so they're going to add together. So that's going to be X plus 60 over here. And we want to end up with coffee that we can charge $6 a pound for that coffee. So we've got some expensive coffee and some cheaper coffee. We're going to make a blend so we get a better taste. Now we're going to look at this in terms of total value. You can call it different things. I'm going to call it total value. And total value is going to be the price times the number of pounds times the amount here. So if we bought 8 pounds of coffee that cost $3 a pound, we would just take the 8 pounds times the $3 per pound, and we would then get our 24, because 8 times 3 is 24 there. Or 10 pounds of coffee would be 30, because we would take the $10 times the $3. That's our total value, price times the amount. So on our first one, what's the value of the first coffee? Well, the first coffee is simply going to be 3x. What about the second coffee? It's going to be $7 a pound, so that's 7 times 60. And then we want to get a $6 per pound type of bean. So that's going to be 6 times x plus 60. And again, you can finish it from here. You should be able to finish it once you've got this equation. We've got 2 more to look at before we start the next section. So 19. How many liters of a 10% alcohol solution are mixed with 90 liters of a 50% solution to get a 20% solution? So this was 18 from before. I'm just labeling that so we know which one it is. Now we're going to look at 19. Mixture problem. So we make our containers here. 1, 2, 3. Each of these have an amount and a percentage rate that goes with it. How many liters of a 10% solution? Unknown amount, X. Percentage rate, 10%. Must be mixed with 90 liters, so that goes over here, of a 50% solution. That goes here. That means box 3, adding across again, is X plus 90. We want to get a 20% solution, so that goes over here. Now we'll look at our pure, and that is the amount times the rate. So our first container is 0.1x. Our second container is 0.5, that's 50%. Times 90, and that is then going to equal 0.2 times x plus 90. You can finish this one on your own. The last question before we move on in the next video to 1.4 is question 20. So we're still in 1.3. We're going to look at question 20. At the end of the day, the storekeeper had $1,260 in the register. That's counting both the sale of the goods and the sales tax of 5%. Find the amount of the tax. So we have a total, and we've talked about these type of problems before, and the total is going to be the amount of the sales plus the tax. We know our total is $1,260. We don't know the sales, so we're going to call the sales X. And what about the tax? Well, that 5%, we can't just leave that all by itself. It has to be attached to something. And 5% again is 0.05. We attach it to that X, so that's 0.05 times X. So that's your equation. I think you can finish it from here because we've talked about these before. Now, X is not going to be your final answer because X represents the sales. We want the amount of the tax. So you can either take that $1,260 and subtract off whatever you find for X, or you can just take the value that you find for X and take 5% of that to get your tax. But X is not your final answer because X is the sales and we want the tax.